Today we're going to talk about friction. So I just want you to imagine that I have a block or some object and I tie a string to it and I start pulling on that object with greater and greater force. That object will not move until I reach some maximum force, and then it'll start to slide across the table. And so what that graph will look like, if I have this block and this force of tension gets greater and greater, if I have like force of tension graphed versus time, that force of tension will increase to a maximum value, and then it's going to decrease and maybe sort of fluctuate as you pull that block across the surface at a constant speed. And so there are two different kinds of friction happening here. The first kind of friction happens while the block is not moving, and that is going to be static friction. And then the second kind of friction happens while the block is moving. That is right here, and that is kinetic friction. Now, what happens at this point, this maximum point? This is where we have the maximum force of static friction. Now you might be thinking to yourself, well, Dr. P, I thought that you graphed tension on this side here. I did, but if we think about the free body diagram of this object, gravity goes down, straight down, normal force perpendicular to the surface. We have that force of tension to the side, and then we have that force of friction backwards. As long as this object is in equilibrium, so either stationary or moving at a constant speed, this object will the force of tension will be equal to the force of friction. So I could have graphed the force of friction here just as easily as the force of tension. So the important thing to note, first things first, the force of static friction is not constant. It can change. It can increase as you increase that pulling force. So the force of static friction, if I wanted to write an equation, F sub S, is going to be less than or equal to this letter mu, Greek letter mu sub S, that's the coefficient of static friction, times the normal force. With that idea, then the maximum force is equal to mu sub S times the normal force. We'll come back to that coefficient of friction in just a minute. So that force of static friction will increase until you get a maximum force. That's the force of static friction, maximum. And then once it starts moving, we have kinetic friction. So I can write the same sort of equation, but substituting in K for kinetic instead of S for static. The kinetic friction, the force of kinetic friction, is always equal to the coefficient of kinetic friction times the normal force. So this idea, if I were to take a block and put a mass on top of it, that's going to increase the normal force. That will make it harder to push. That's going to increase the force of friction. What are the things that affect the force of friction? The normal force, we just talked about that. The type of surface, is it rough? Is it not rough? And that's not just the one surface that it's being drug across, but that's the two forces that are rubbing against each other. So the tabletop and a wooden block versus the tabletop and maybe a block that has fabric on it. Okay, so those are the two things that affect it. You might think surface area. That does not affect the force of friction. Neither does the velocity that you pull with, or the velocity of an object. That doesn't affect the force of friction either, which is good because that would be super complicated if the force of friction was affected by how fast something was moving. Okay, so let's talk briefly about this mu sub K. This is the coefficient of friction. Okay, the coefficient of friction, and that can be static or kinetic. Coefficients are just numbers, okay? So this is the one thing that we're going to have in physics at this moment that does not have a unit. So it's just a number. Typically that number is between 0 and 1. It can be greater, but oftentimes we don't really see that. What that tells us is how rough those surfaces are. So a rougher pairing of surfaces gives us a bigger coefficient of friction. Now, we see up at the top, we see when we look at this graph that the force of static friction, the maximum force of static friction, is greater than the force of kinetic friction. So Fs max is greater than F sub k. This means that the normal force is the same, so that means that the coefficient of static friction has to be bigger than the coefficient of kinetic friction. How would we find that coefficient? Well, we can just go back to these equations down at the bottom here. We can go back to this equation here. If we divide both sides by the normal force, we end up with the force of kinetic friction over the normal force is that coefficient of kinetic friction. Same deal with static friction, except it's not just any static friction, it's the maximum force of static friction. So this is how you can see that there's no units on this number, because the unit for force of kinetic friction would be newtons divided by the unit for that normal force, which would be newtons, and those two forces will cancel out. So let's go ahead and calculate the coefficient of kinetic friction for a block that's being pulled at a constant speed across a table. So the mass of the block is going to be 1.2 kilograms, and that pulling force that's moving at a constant speed, that force of tension, will be 3 newtons. Okay, so first things first, we draw a picture. Then the second step is going to be to draw a free body diagram. So I'm just going to draw mine down here. I have that force of gravity, which is the weight, which is the mass of the object times the gravitational field strength. So 1.2 kilograms times 10 meters per second squared. So my weight, or my force of gravity, will be equal to 12 newtons. My upward force, my normal force, and then I get my sideways force of tension and my backwards force of friction. And I'm just going to label that F sub k. Now, my pulling force of tension is 3 newtons. This block is moving at a constant speed, which means that it is in equilibrium. So the left forces equal the right forces. So my force of kinetic friction is 3 newtons. The up forces equal the down forces. So my normal force is 12 newtons. Okay, so step 3, oftentimes in solving a problem, is to sum the forces in the x and y directions. I already did that when I was drawing my free body diagram. I have my equal forces 3 newtons on each side, my equal forces 12 newtons on each side. So we start with that equation that the force of kinetic friction is mu sub k times the normal force, divide both sides by the normal force. I will always plug my numbers in at the very end, so I'm going to go ahead and call the normal force my weight, or mg, and then I end up with mu sub k is 3 newtons for my force of kinetic friction divided by 12 newtons, and I end up with my mu sub k of 0.25 as my coefficient of kinetic friction. This is just a coefficient table for different coefficients of friction for surfaces that are rubbing together, whether it's static friction or kinetic friction. Notice that the coefficient of static friction is always greater than the coefficient of kinetic friction. It is easier to keep those bonds of those two surfaces from forming than it is to break them at the beginning. So static friction is always bigger than kinetic friction, meaning that the coefficient is always bigger as well.